Q6811. For an airplane with reciprocating, non-turbocharged engines, VMC, A. Decreases with altitude. B. Increases with altitude. C. Is not affected by altitude. The correct answer is A. For an airplane with reciprocating, non-turbocharged engines, VMC, velocity minimum control, decreases with altitude is the minimum airspeed at which the airplane remains controllable with the critical engines suddenly made inoperative and the remaining engines at takeoff power. It represents the minimum speed required to maintain control during an engine failure scenario. At higher altitudes, the air density decreases. As the air density decreases, the available thrust from the engines also decreases. Since VMC is based on the minimum controllable airspeed with one engine inoperative, the decrease in available thrust at higher altitudes reduces the margin of controllability. Therefore, as altitude increases, the available thrust decreases, resulting in a decrease in VMC. This means that the minimum controllable airspeed required to maintain control during an engine failure scenario becomes lower at higher altitudes. For an airplane with reciprocating, non-turbocharged engines, VMC decreases with altitude. 6812, which is true regarding the operation of a multi-engine airplane with one engine inoperative. A. Banking toward the operating engine increases VMC. B. Banking toward the inoperative engine increases VMC. C. VMC is a design performance factor which must be proven during type certification and will not change as long as the ball is centered with appropriate rudder pressure. The correct answer is B. When operating a multi-engine airplane with one engine inoperative, banking toward the inoperative engine increases VMC, velocity minimum control. The VMC is the minimum airspeed at which the airplane remains controllable when one engine is suddenly made inoperative and the remaining engines are operating at takeoff power. It is an important parameter that pilots must be aware of during engine-out situations. Banking toward the inoperative engine creates an asymmetrical thrust condition. This means that the operating engine is producing more thrust than the inoperative engine. Asymmetric thrust causes a yawing moment around the airplane's vertical axis, which must be counteracted with rudder input to maintain directional control. When banking toward the inoperative engine, the vertical component of the asymmetric thrust increases, which further exacerbates the yawing moment. This increase in yawing moment puts additional demands on the remaining engine and rudder control to maintain control of the airplane. As a result, banking toward the inoperative engine increases the demands on the controllability of the airplane and raises the VMC. This means that a higher airspeed is required to maintain control in the presence of the increased yawing moment. Therefore, the correct answer is banking toward the inoperative engine increases VMC. 6813. Which condition causes VMC to be the highest? A. CG is at the most forward allowable position. B. CG is at the most rearward allowable position. C. Gross weight is at the maximum allowable value. The correct answer is B. The condition that causes VMC, velocity minimum control, to be the highest is when the aircraft's center of gravity, CG, is at the most rearward allowable position is the minimum airspeed at which the aircraft remains controllable with one engine inoperative and the remaining engines operating at takeoff power. It is an important parameter for multi-engine aircraft operations. The position of the CG has a significant impact on the aircraft's stability and control characteristics. When the CG is at the most rearward allowable position, it affects the balance and distribution of the aircraft's weight. With the CG at the most rearward position, the aircraft's longitudinal stability is reduced. This means that the aircraft becomes more prone to pitch instability and has a tendency to pitch up. As a result, the aircraft's control surfaces, particularly the elevator, have to work harder to maintain control and counteract the pitch-up tendency. During an engine-out situation, when one engine is inoperative, the operating engine generates asymmetric thrust, causing yawing moments around the aircraft's vertical axis. The aircraft relies on the vertical stabilizer and rudder to counteract these yawing moments and maintain directional control. When the CG is at the most rearward position, the increased pitch instability can make it more challenging for the vertical stabilizer and rudder to counteract the yawing moments effectively. This increases the demands on the control surfaces and reduces the margin of controllability. Therefore, when the CG is at the most rearward allowable position, VMC is the highest. This means that a higher airspeed is required to maintain control in the presence of the increased yawing moments and reduced longitudinal stability. Hence, the correct answer is CG is at the most rearward allowable position. 6619. The V&E of a helicopter is limited by A. Centrifugal twisting moment of the rotor blades. B. Lateral controllability or retreating blade stall. C. Available horsepower of the engine, which may be converted to torque. The correct answer is B. The V&E, velocity never exceed, of a helicopter is limited by lateral controllability or retreating blade stall. During high-speed flight, helicopters experience asymmetric lift distribution on the rotor blades. The advancing blade generates more lift due to increased airflow, while the retreating blade generates less lift due to decreased airflow. As a result, the retreating blade can reach a critical angle of attack and stall, leading to an unbalanced lift distribution. To ensure safe operations, the V&E is set below the speed at which retreating blade stall can occur. This limitation is necessary to maintain lateral controllability, preventing uncontrollable rolling or yawing of the helicopter. While factors like the centrifugal twisting moment of the rotor blades and the available horsepower of the engine can indirectly affect helicopter performance, they are not the primary factors that limit the V&E. Instead, it is the potential loss of lateral controllability or retreating blade stall that imposes the maximum allowable airspeed on a helicopter. Therefore, the correct answer is that the V&E of a helicopter is limited by lateral controllability or retreating blade stall. 6830. The most favorable combination of conditions for rotorcraft performance is A. Low density altitude, low gross weight, and moderate to strong wind. B. Low density altitude, high gross weight, and calm to light wind. C. High density altitude, low gross weight, and moderate to strong wind. The correct answer is A. The most favorable combination of conditions for rotorcraft performance is low density altitude, low gross weight, and moderate to strong wind. 1. Low density altitude. Density altitude is the pressure altitude corrected for non-standard temperature. It is an indicator of air density, which significantly affects rotorcraft performance. In low-density altitude conditions, the air is denser, providing better lift for the rotor blades. This allows the rotorcraft to generate more thrust, resulting in improved performance in terms of climb rate, maneuverability, and overall efficiency. 2. Low gross weight. Gross weight refers to the total weight of the rotorcraft, including the aircraft, occupants, fuel, and cargo. A lower gross weight reduces the overall load on the rotor system and increases the power-to-weight ratio. With a lower weight, the rotorcraft can achieve higher climb rates, faster acceleration, and improved maneuverability. 3. Moderate to strong wind. Moderate to strong wind conditions can be favorable for rotorcraft performance. A moderate headwind component can increase the airspeed over the rotor blades, enhancing lift and allowing for improved climb performance. Strong winds can also provide additional lift and help counteract the effects of higher density altitudes. By combining these three conditions, low density altitude, low gross weight, and moderate to strong wind, the rotorcraft can achieve optimal performance. The denser air at low density altitude provides better lift, the lower gross weight improves the power-to-weight ratio, and the moderate to strong wind enhances the rotorcraft's performance capabilities. Therefore, the correct answer is that the most favorable combination of conditions for rotorcraft performance is low density altitude, low gross weight, and moderate to strong wind.